FDP पे भी आया हुआ है सर, मैंने किया हुआ है मेरा ना। सर भेज रहे हो सर, वो FDP वाले पे भी डाला हुआ है वैसे। FDP चलो जहाँ से आपको डालना। आगे वो कहाँ पर है पंकज सर? वो कहाँ पर है सर जिनका आज है? मेरे पास नंबर ही नहीं है ना। Abhishek sir, are you there? Abhishek sir, are you there? Yes, sir, he is there. Okay, okay. All right, sir.
Yes, now.
Yeah, I
Yeah,
just
good,
make
good
you
morning.
present.
Yeah.
Very good morning. I make you a presenter, sir. Yeah.
Sure, sure, sure. Yeah, I was not actually able to speak because I didn't have the access.
All
So
right. Yeah.
yeah.
हो गया ठीक है राइट
डिफरेंट होता है सर।
Please do let me know when I should start.
Yes sir, sure. Am I audible?
Yes.
Okay. Good morning, everyone. Anthony J. D. Angelo rightly said, develop a passion for learning. If you do, you will never cease to grow. With this belief, I, Dr. Tripti Lamba, Associate Professor in Computer Science Department, welcomes you all to the third day of our Faculty Development Program on Emergence of Blockchain, Technology and Cryptocurrency. The session is hosted by IITM, Institute of Information Technology and Management, affiliated to Guru Gobind Singh Indraprasth University, New Delhi, having 22 years of academic excellence since 1999. It gives me an immense pleasure that we have successfully conducted 2 days FDP. In these 2 days, we had eminent speaker having expertise on the blockchain theme, and I extend my gratitude to those speakers, Dr. Bharat Bhushan, Professor Dr. Jublan J, Dr. Rahul Jori, and Dr. Kiran Chaudhary. Now, moving ahead, in the third day of the FDP, I welcome our first speaker of the day, Mr. Abhishek Bhattacharya. Mr. Abhishek Bhattacharya is a multifaceted personality who is a successful 3x entrepreneur, widely acclaimed 2x author, advisor to startup, educator with ODEM, on-demand education marketplace, speaker at various international forums, nominee for various global awards, among other accomplishments. He has achieved many laurels at a very young age. Mr. Abhishek Bhattacharya is a co-founder at WHRRL. At WHRRL, he is building India's first agri-lending blockchain that we can save 25 to 40% of the farmer's income and protect banks from millions in frauds. He has been an advisor to several startups such as esports.com, who raised 5.8 million euro in their ICO. Vilia, Blockchain Advisory Council, Navcoin et al. His second book, Secure Chain, Cybersecurity and Blockchain-Powered Automation, has been published by BPB Publication, Asia's largest publisher of IT books. He was also nominated for the Top 50 Tech Leaders awarded by Intercon Dubai. And the list does not end here, it is endless. I have highlighted some of his major achievements and nominations. Now, I take this opportunity to invite Mr. Abhishek Bhattacharya and gain from his experience and insights. Over to you, sir.
Thank you, ma'am. Thank you so much. That was a wonderful introduction. It's a pleasure and a privilege to be presenting here at this FDP. I hope I'm audible, ma'am. Can you please
sir,
just
you are very much audible, and it's our pleasure that you came out here, sir.
Thank you, ma'am. I'll just share my screen and just give me a second.
Yeah.
Okay. 1 second. Is the presentation visible?
Yes, sir, it is visible, sir.
Okay, all right. So I'll just full screen it and I'll hope it's still visible.
Yes, sir, it's visible.
All right. So I'll get started, but my video may have closed. It seems that Microsoft Teams just closes the video when I start sharing. So I'll go this way. Thank you so much, everyone. Welcome and good morning here to be present at this quick hands-on that we are doing. It is not a quick hands-on, though what we have in store for you today is essentially we are going to be creating a private blockchain locally, and this helps everyone. This helps developers, this helps students in the past that I've taught, faculty whom I've taught, to just create a blockchain from scratch locally and get started developing applications on top of it, or writing out smart contracts which you can test on top of the local Ethereum blockchain. This lecture typically is not of 1 hour. It's mostly, it sometimes take 2 hours and beyond. So I may go a bit fast, but then I have put out a method so that there is no learning gap as I deem it to be. So for that, what I've done actually is that I'll just exit it. So towards the end, I will be sharing a list of resources. Here, the first 2 resources, this is very important for all of you to see. Here, the first 2 resources that you see are the step-by-step recording of what I'm showing here, or what I usually demo in a class of entirely 2.5 or 3 hours. But this is a very short step-by-step recording of the same steps in under 14-15 minutes. So this should help you. This should help you in understanding what all commands I'm doing in class today, and if I'm doing it very fast, and this should help you follow along. And while doing so, I'll also share my credentials at the end. You can please reach out. I understand 1 hour is going to be very, very less for getting through a hands-on, but I will be sharing my credentials at the end. You can take a screenshot or just copy it down and just get in touch with me or the university, and we'll make sure that if you are having any problem following the resources, the step-by-step recording of the steps that I'm performing today, if you have any problems, you get stuck anywhere, please reach out to me, WhatsApp, email, anything, and I would make sure that there is no learning gap again. So that's it. Please make sure that I will be sharing this presentation with ma'am right after this lecture. All right, so I'll get started. I'm not going. Yes, yes, ma'am.
So can you just check it can be on your camera?
No, I can't. It says that you can share. I just, you can. It says that you can share your video when you're done screen sharing.
All right.
So
okay,
it prohibits me from. Just the moment I started screen sharing, it's switched off the camera.
Okay, fine.
I think I'll have to go ahead this way.
Yeah.
Okay. So all right. So yeah, please make sure that you look at the references and resources at the end of the lecture. And I'm not going full screen now, so I hope it's still visible. I'll just do this a bit. And all right. And a very good introduction was already given by Matt, so I won't spend a lot of time here. We're already low on time, but I'm running currently India's largest blockchain network, where we are doing agri-financing. Please reach out if it at all is a relevant use case for you, or anything else in blockchain that you believe that is going to be useful for you to discuss. I'm your person, I'm your guy. Please reach out, and let's see what we can collaborate and how I can help you do anything that you want in blockchain. This is our agenda. I'm going a bit fast, but as I said that we have less time. This is our agenda for today. We are going to be very specifically setting up an entire private Ethereum blockchain. Locally, we'll try and understand the Genesis block, which by the time now in this particular FDP or before, you may have already heard of what a Genesis block is. Then we'll add nodes to the private network. We'll create an initial first account, which is also called a Coinbase account, and we'll do so on both the nodes. And we will try committing a transaction between the 2 nodes to show that, yes, they are in sync. And that is what you need. So when you, even after beyond this class, if your students or anyone wants to try this out, then ideally you should be able to commit transaction between the 2 nodes that you add. That's the most important part. In fact, this can be called as the most important part of the lecture, so that you understand that, yes, when I deploy a transaction or when I deploy a smart contract, it will be as expected. It will be deployed as expected. Then we'll mine some blocks on that local Ethereum blockchain. We'll use some popular RPCs, remote procedural calls, and we'll see that what they can do, how can they come, and when can they come handy, in what scenarios. We'll look at some popular RPCs, which I've also listed on this presentation and which you'll get after this class. And we'll check the transactions and see what we can do. And out of these all items, maybe we may not be able to cover all of it in 1 hour, but I did not skip them putting on the agenda or on this presentation, because even if I'm not covering them here by 11:30 a.m., you'll again get this presentation and the resources to follow along yourself. So even if we can't cover, I've not deleted from here. All right, so let's get started. Also, one more thing that I've done is I have, I hope, ma'am, can you also see my terminal now? Can someone please confirm? Can you see the terminal? Okay, all right. So we'll start here. We'll start by creating one of the nodes. What I'll do is I'll go ahead and I'll put in the chat something which I've kept here so that it comes handy for us while doing this. So I'll just start and get started with each command that I'll be doing. I'll be putting here in the chat so that you can follow along as well. Okay, I don't
Only PPT is visible. Terminal.
Okay, I got it. I got it. Yeah, I think, yeah, okay. Then I need to share my entire screen. I hope it should be visible now. Is it visible now if I go for terminal?
Yes, sir. Now it's visible.
Okay, and before this, I was showing that I have listed all the commands here, which I'll be putting in. So while putting in a particular command, I'll go here and I'll put in the chat of which command I'm following. And also I'll include them in the presentation. I'll add them before giving it to ma'am later after this lecture. Ma'am, I don't have access to the chat. Is it possible for you to give access to the chat so that I can post? By the time ma'am is doing that, I'll just go ahead and we'll start off with something. So one command that I'm doing here right now, again, no need to write down or no need to follow anything like this. I hope the agenda is clear. That's most important. The agenda is we'll first create a private blockchain network, a private Ethereum network. And as you know, Ethereum is a second generation blockchain, and it brought with it the capabilities of smart contract development, which has changed the landscape altogether since years now. And everything that even what I do at my startup, when we give loans to farmers or we do deliveries on the network, do receipts on the network, any kind of thing that we do on the blockchain network are governed by smart contracts. That's how important smart contracts are. And let me see. Yes, there are some pointers to keep in mind before we start. Your private Ethereum blockchain does not mean that it is completely running in a vacuum, that it is completely running in an air-gapped system. It actually means that other nodes can still find it. How? I'll just show you. I'll just show you how we'll be using all details, which anyways, maybe in the second part of this particular lecture, we will be using to connect our second node with the first node that we've created. Similarly, just because the second node is residing on your computer does not, so that's you know how it works, that it is not able to connect to your first node because it is on the same computer. It is again connecting via network. So similarly, in fact, anyone out of all the, I think we have quite a lot of people out of all the 132 people we have right now on this particular session, anyone who's following along can also try and connect to my network. Let's not do that because that will create a bit of a problem with my own demo. But yeah, of course, if nonetheless, we'll see how we can do that. But yeah, then this is one of the pointers that we must keep in mind, that any other node can find you as well. It's not completely vacuum. Network ID parameter, which we'll use, is very, very important. As you can see here, this is what I'm talking about. This is very important because this tells get, which is Go Ethereum, Ethereum's client written in Go language, which is this get I'm talking about, that which network to connect to. This network ID is pretty random, but make sure that you actually use something that is random. Do not use 1, 2, 3, 4, 7, 17. All these are networks which you can just do a Google search and find that these are network IDs which are reserved or already being used by currently existing networks. For example, one network ID 1 is Ethereum mainnet, which we know of. 2, 3, 4 are possibly the test nets. And similarly, other networks are there. So make sure that because you do not have a limit here, you use something truly randomized. Otherwise, you'll by mistake connect to one of the existing networks and it will not allow you to do your demo or my demo as expected. And third thing, we are using, yes, ma'am. No, I don't have access to the chat.
No?
As you can also see on the screen. Yes. Otherwise, otherwise just people will follow along, and if that's not possible, then maybe just everyone can follow along. And I'll anyways be giving all these commands, all the resources after this lecture anyways. So I hope that's helpful. So they'll get this recording plus I think my recording as well. So I think that should work. All right. And last thing, we are using allow insecure unlock to be able to use those to be able to do those transactions, which we are going to do as test transactions here, as we discussed that we'll do commit transaction between addresses on different nodes. Just to be able to do here, we are doing this allow insecure unlock in our code right now. Why I kept this pointer out, because you do not do this on a production system. You just do it on a demo. You just do it on a local system. Do not do it while setting up a production environment at all. So that was something we wanted to, I thought that we should keep in mind before we begin. We still have 45 minutes to go. I know I may have caught up a lot of speed, but I will be available to you after the lecture anytime you want, even 2 years from now, and you come back and say that that video is still not clear, or I'm not able to do any of those commands, I will be there. I hope I'll be there in blockchain till then, which I plan to do. So this is what we are going to do. You can see that the first command is itself here. I see if the chat is not enabled. So what I'll do is you can see the commands on screen. We'll run these commands, and I'll explain the agenda of this entire lecture is not for you to immediately set up an entire hands-on blockchain network within 1 hour of also seeing me do so and doing it parallelly. For this only, I said earlier that it sometimes takes around 3.5 hours. But the agenda is to be able to understand that what I am showing here. Why I'm doing something, what do these mean? People who have more than 100 is to make sure that there is no gap in learning, to understand what exactly I'm doing and why are we doing something like that. Muted. Is there a question? Also, if there is any question, then please do write in the chat, or maybe ma'am will let me know, or just you can speak out. Okay. All right. And if you're not speaking, please try to keep your mic on mute. So this is where we'll start, and I'll tell you while doing what are we doing. This is an example command, and we'll start with that. So here, first of all, what do? We first of all want to be able to create nodes. What are nodes? Nodes are exactly what a blockchain network is entirely made up of. By now, especially in this FDP, in the sessions I've seen that earlier may have covered parts of this, or in the past you may have studied by now, known by now, that how a blockchain network works from basics, the fundamentals of it, then what nodes do in a blockchain network, how nodes operate in a blockchain network. So that's what we are creating. We are creating 2 independent blockchain networks, nodes, and then we'll make sure that they are part of the same blockchain network, which is where I told you earlier that we are going to use the network ID parameter, which is very, very important, but has to be randomized. They have to be part of one network. If you just don't use this and you use one, it is just as good as using it without network ID. By default, it takes 1, and 1 means the Ethereum mainnet that we know of, which would mean that anything you want to do on Ethereum mainnet will consume Ether, which has real life value, which will mean that it will cost you heavily if you try to test things on mainnet. So it's best that you use anything like this, or you can use anything very randomized, which can be just like this. These are all random network IDs which you can use to connect to. All right. So going ahead. So first of all, let's just quickly do this in a particular environment that we create. Let's just create a directory. We'll name it IITM. We've done that. We'll go inside. And now here we'll create both the nodes. So how do we start creating nodes? That's what we saw earlier. We start with get. Get, as I said earlier, is, I'll just zoom in a bit so that it's more visible. Yeah, I hope it is visible. Ma'am, can you please confirm, or someone, can you confirm that whether the text inside the terminal is visible enough? All right. Okay. Thank you, ma'am. So we'll start with get. We start with get because it is what is to signify that get we are using Go Ethereum version. So Ethereum's client written in Go. This is one of the most popular versions. If you visit etherscan.io and you see how many nodes are. Yes. Is there a question? Okay. All right. So if you go ahead and see how many nodes are running Ethereum, Go Ethereum client, you'll see that plenty of them are running Go Ethereum based clients. So we'll start with get. That's what it does. In fact, if you want to test, if you're following along and someone have get already installed on your system, can just go ahead and do this. Just typing get will show you a lot of characters, a lot of words happening on screen. I've just written get. I've not done anything. If you see here, I've just written get and I pressed enter, which means that it will connect me to the default network. And I told you the default network ID is 1, which means that it will now try to connect me with the Ethereum mainnet. So what does this mean? If I leave this for now in one of the terminals open and leave it for maybe in the next 2 days here, it will gradually start downloading the current Ethereum network, which, if I'm not wrong, is around 220 GBs or 230 GBs of data of all the blocks that have happened here, right? Starting from the 0th block, which was done by Vitalik Buterin back in 2015, July 2015, up till the latest block, whichever will be happening at that, like as we go, like the latest block now, and then the new blocks that will be generated will be synced with this node that I just ran from here. So by the way, I just connected to the Ethereum network by being a node. So this was me being a node. Writing get here was me turning into a node because I have all the characteristics of being a node, and I just connected to the mainnet. You can see here starting get on Ethereum mainnet. But again, why did I do this? This was not a part of the planned demo, but why did I just press enter and show this? Is because we don't want to do this. We don't want to do this because this is equivalent to using network ID as one, and we don't really want to do this because you may not be having that kind of space to accommodate the entire Ethereum network on your laptop, especially if you're using a Mac or something, and you don't want to do that. That's not where you want to test. The agenda is to create a private Ethereum network. That's it. So we'll start with get. The first switch that we use is data dir. As the name suggests, again, for people who join new, all these commands, as you can see here, all these commands I will be giving to you separately on the PPT as well. I'll edit the PPT, and also it is available there in the resources section in one of the videos. So don't worry of copying or writing down the commands at all at this point in time. You can just follow along. You can just try to understand that what every switch means and why are we doing something while doing so on the screen. So get, then data dir, we start with this. We signify that, okay, data dirs, as pretty self-explanatory it is, it means that this is going to be the directory where we want all our entirety of our blockchain data to be stored. So let's name it IITM 01. For example, you can do anything. You can name this directory anything. Does not matter. This is your node's name, and that's all. You're not going to use this name while creating the second node and trying to connect with this. You're not going to use this name. What you're going to use is something else called enode, which acts like the IP address or the location of this particular node. So this name does not matter. You can keep anything as you like. So we'll start with this. There is one thing that we need to do, which I don't have here, so I'll just copy it from here. Something that we must have, which I will also provide I have already provided on the PPT here. You can copy from here. You can see here that this is what is called the Genesis file. I hope it's visible on the screen. This Genesis file, you can see here, shows the configuration that we want to do for this particular, while starting this blockchain, and what is the configuration that we want it to follow. So you can see here that we start with the chain ID. We then specify certain block numbers: Homestead block, EIP 150, Byzantium, Constantinople. All these are configurations that we want to specify because these are forks that have happened in the past. Again, out of the context of this particular lecture a bit, you may have studied forks, hard forks, and soft forks in blockchain in the past in any of the lectures. So many a times Ethereum has gone through all these forks. So these are Homestead, EIP 150, 155, 160, Byzantium, Constantinople, and then just 2 days or 3 days back, if I'm not wrong, the London fork happened on the Ethereum network. So all these are forks where Ethereum has changed. Either they have been planned or unplanned. In the planned scenario, Ethereum has upgraded their client up a notch to for certain changes in transactions or certain changes in, for example, the way transactions are handled, the way blocks are handled, size of the blocks, or fee. London is all about fee. If you read about it, it's EIP 1559. It is all about the fees and how fees is handled and what fees is burned later on. But yeah, out of scope of this lecture, so won't go into that. It will take itself an entire 15-20 minute discussion. But yeah, you can read about it later. And this is what we specify here. So it is very important for us to specify all these configurations in our Genesis block and then in a Genesis file. And then we will be using the same Genesis file across all our nodes. Today we are creating 2 nodes, whatever time permits. If I don't have that kind of time, then again, you have the resources. Do not forget, anyone who's joined later, do not forget, you have these resources right after the lecture is over. The first one you can see here is exactly what I'm showing here in 1 hour or what I've done in the past in over 3.5 hours, but this YouTube video will give the same commands to you in less than 15 minutes. It's just that it does not have an audio. So make sure that you listen to the audio right now and follow the commands there later on. And the second video, for those who are good with the first one, second video, we are not doing this one. This is not doing today. Smart contract, we are not even touching today. Maybe someday else, next time we do this. But once everyone is good with following the commands in the first video, if you're running a private blockchain Ethereum, a private Ethereum blockchain on your local, second video is something that you can try out. There we interact with Remix. We make sure that Remix, which is an integrated development environment to write smart contracts, run, deploy smart contracts inside your browser. So we make sure that your Remix IDE is able to access your private blockchain Ethereum, is able to recognize that your network ID that it is running is able to access that. And then once you deploy your smart contract, it is actually deployed on your local private blockchain, and you can see the changes happening. Not covering today, but I still put it here. I will still put it here in the resources section, as you can see, for you to follow along if you are able to reach there. All right, so this is what Genesis block is all about. So we make sure that the Genesis block is something that we keep. So you can see that you can see here that this is the same Genesis block that I put there, which is what I'm using here, and make sure you use the same Genesis block. There might come that if you take one Genesis block from the internet, you may face significant problems. Because if some of these configurations are not present there, which I faced, and then I changed the Genesis block myself, and now it is working pretty well. So make sure that you can copy and paste this from the Genesis file that I give you along with the presentation, or directly from the presentation. This is the configuration that we are going to go ahead with. You can see that we've kept difficulty and gas limit as pretty low. Gas limit is still good. Difficulty is pretty low. Why? Again, quickly touching upon this factor, difficulty is how difficult it is to mine new blocks on this particular blockchain network. If you right now go and check it in the let's immediately do it, even if not a part of the demo, but will take 2 minutes. If you immediately go, I hope it's visible. If we go and we check here, the current difficulty is 7947 terahashes. That's humongous. That's a huge level of difficulty for mining blocks that is there in the Ethereum network right now. This is the Ethereum mainnet we are talking about. On the other hand, what we've put here is in hexadecimals a very low difficulty. Why? Because Ethereum network, as we are seeing here, Ethereum network has a lot of mining power, a lot of miners, and it has to have this difficulty, right, to mine blocks, so that it always takes between 15 to 19 seconds for one block to be made. You can see here, you can follow along, every block will be taking around 15 to 20 seconds. But here, but there's a lot of mining power involved because there are thousands and thousands of miners on the Ethereum blockchain. On the other hand, here we are the only miner, and we don't want to put pressure on our computer when we are just doing a demo. So we keep the difficulty very, very low. Yeah. All right. So I hope that is clear. So something I'm going to do is there a question? Someone is unmuted. Is there a question? Okay. All right. So what I'm going to do is I'm going to copy it here, and I hope I'm able to run this here then. So what we do is, okay, if you have a question, please do let me know. Otherwise, I request you to please keep your mic on mute, because I think then there is a question. So we started coming back here. We started get, we did data dir, IITM 01. You can name it anything. You can name it Abhishek 01 if I would have done that. Anything. Then we used init, which is of course for initialize, and initialize that with genesis.json file, which you can see here on the right side is this genesis.json file, which you'll get after the lecture from the college, from the university. So this is what we do. We set that, okay, let's initialize this particular blockchain where the first node is IITM 01 with the file genesis.json. I hope it runs. Anytime demos, usually sometimes demos go bad. So anytime that happens, I myself will switch to the video and quickly get that done to show it to you. So that's done. Now, one thing is that if you go ahead and if we just see what is inside IITM 01, you can see here. There is a folder called key store, which again is going to be, currently it is going to be blank. You can see it is blank, right? Key store is currently blank. This is where all your wallets will be stored once we make them. On the other hand, if we take a look at get, the folder, the another folder that was created, you can see that there is another directory called chain data. This is what I was talking to you about earlier, that chain data inside this get folder, inside your IITM 01, which is your node, first node. This is the directory that will contain all your blocks that you are making. This is the directory that will contain the entirety of the blockchain. So the blockchain that you know, the ledger that you know, is actually stored inside this. And the private keys and the accounts are stored in the key store file folder, which we saw up here, which is currently empty. But the moment we make the first account, it will put it here. All right, not wasting time here much, going back. You can see we are back here. The next thing we are going to do is now we are going to start the blockchain network. Currently, we have just started the node, and we have not started. We have initialized a blockchain network. We have not started the blockchain network entirely. For that, here we are. I'm again going to copy from here, but I'll let you know that what are we doing and why are we doing. Let's start with this. So as you can see here that we have put some details. Let's go back and let's see what it is, what they are. Again, starting from here, I hope you can see the cursor as well. Starting from here, we start with get again, data dir again. As you know, this is like the data directory, which is where again the blockchain is stored, which is where we are fetching the blockchain from. We will use our new directory that we've created here, which is going to be IITM 01. So get data dir IITM 01. Now no init because initialization has already been done. So what else? Now this is the most crucial command that you're running, because this is where the blockchain either starts or does not. It has also happened in the past many times with myself that even if it's a very proper looking command without any problems, right, like it's right looking right now, it has many times happened that right after I press enter, the blockchain has not run, and then it becomes a different whole ball game altogether to check why is the blockchain not running. That's an entire issue. And with many of my students, it has also happened that they had to come back to me sharing their logs, sharing their screenshots, that why is this not running, and then I had to do it with their commands at my end and see that what is the problem. So again, if that is the kind of problem that you're facing, I've given my credentials earlier. I'll also give it right after this lecture at 11:30. Please reach out to me. Let me know what problem you're facing, and we'll solve it together over electronically, of course. So yeah, we start with this. We go into IITM 01, and then we start specifying the various items. First, we're going to use RPC, remote procedure call. Of course, that's something that we want to tell get that yes, of course, this is something we will start using, because this is how we will be talking to the blockchain. Here already, I know that the kind of background this particular audience has, so I don't need to tell what RPC is. But just to tell here, a note to add is that RPC is how we are going to access our entire blockchain network, starting from. Yes, ma'am.
I'm sorry to disturb you, sir. We are live on YouTube also. So the
All
screen
right.
is bit, can you just zoom it a bit, sir? The Teams is okay, but in a YouTube, yeah, bit blur.
Okay, I just zoomed it twice. I hope it still stays intact. Okay, all right. So I just zoomed in a bit more.
Okay, thank you, sir.
Come on. Okay, that's great. So everyone joining us from YouTube, again, you may not get the files directly from the university after this lecture, but yeah, if you stay put till the end, you'll see my credentials. You can ask for the Genesis blog or any of these commands or the presentation on whole altogether from me directly as well, if you're not viewing this in MS Teams. All right. So I hope it is visible now. So we'll go back again. We'll do the edit, which we just did. Here we are, and now RPC, we are going to check what all RPCs we take in just a bit. And this is how we'll talk to our blockchain network, because we want to be able to see how many current blocks are there, what is a hash, what is the account, create a new account, all these actions from individual RPCs that are available to us from Geth. We're going to do RPC, another switch is RPC calls domain, which is telling us what kind of domain, cross object response domain access that we are having, where I've specified a star. While doing it on production, this is again another caution which I've not shared on the PPT earlier, is that this is where you might again want to be cautious about where you're allowing these CORS requests to CORS requests to come. Currently, I put it star, so anyone from anywhere from Remix or any other domain, any other IP address can access or can send RPC CORS requests. But you might be willing to do it separately in a different manner somewhere else when you're doing it in a production environment. Then RPC address, which is going to be, I am again allowing anyone to access these RPC ports. Again, I've used 0.0.0.0, but you want to be able to make it streamlined and make sure that you're using as per your expectations. Later on, for demo purposes, this is perfectly fine. And anyone looking at the look at this in the YouTube as well, if you're following along, you can follow the same items as well, just as I've put here. Network ID. Now, again, as I told you earlier, this network ID has to be completely random. Do not make sure that we just saw earlier. When I just wrote get and pressed enter, it meant that it's connected to the Ethereum mainnet. So do not use one. Do not use one here. Make any random thing. You can use 45451. You can use that. 45451 is pretty random. How many people would have thought about this kind of a random number and set their network IDs? So make sure you use something random, but remember it because that's what you'll use to connect your second node to. Then RPC APIs. The switch RPC API. Again, anyone watching, do not need to write this because all of this will be provided at the end of the lecture, which you can copy paste from. We are using RPC APIs of ETH, Web3, Personal, Net, Miner. These are what comes to my mind right now. If anything else is there, we would be willing to use that as well. ETH, again, will be accessing the blocks using this ETH, the block number, just a wrapped version of ETH. Personal is going to allow us to create new accounts and unlock those accounts. We'll see how. Net is going to give us access to similar personal items and also some admin items. Miner is, of course, we'll use for miner.start and miner.stop, which I shared earlier is going to be this part. This part where we are in the agenda. Yeah, in the agenda when we are doing, say for example, we want to be able to access, the accounts, or we want to be able to do some transactions. We want to be able to start and stop mining and so on. So these are why we're going to use that. So miner. Then comes the port. Port, you can again, the default port, by the way, to let you know, the default port you'll find on the internet is 30303. You can use anything. We can use for this lecture, we can use 30309 as a random port. RPC port, the default one is 8545. We can use something like 8547 or something more random like 8552, for example, 8552. Again, random, right? But make sure that these are not very random. Like, that the maximum number of ports we can have are 65,536. So make sure you don't do something like this with a huge number, like you've done in network ID. You don't do that with port. All right. Very important. One very important part here is this no discover. We've used this switch no discover to make sure, I'm talking about this switch, if you're not able to follow. No discover means that we don't want to be able to, we don't want a node to look out for other new nodes to be peers of automatically. What happens is that if you don't use this switch, then constantly it'll look for peers, look for peers, look for peers. It's going to do this constantly. We don't want that to happen. And at the end, we are using allow insecure unlock, because as I said earlier, this is not something you should do on a production system, but here we're going to do for demo purposes only. And we are writing console because not only we are starting the blockchain, but we also want to be able to speak to the blockchain, want to be able to interact with the blockchain. So this will, as the name suggests, this will open up a console for us while this blockchain network is being deployed. If you leave this out, then you'll have to open another terminal, let this blockchain run here in this particular terminal, and in that new terminal, go into this folder, and then again do a get, attach, and console kind of a thing, so that you're able to access. So it's better to use it all together. Don't need to write any of these commands, all will be provided to you. All right, I'm going to press enter, fingers crossed, hoping that things work. So things have worked, as you can see on the screen, and it has the blockchain has started. You can see at block 0, which means that of course this has started, and no blocks have happened yet, and that's all. You can see that now, not here. Where did it go? I'll try to find what I'm trying to find. Okay, it seems I've lost it. In any case, all right, never mind. Okay, I wanted to show you something, but I think I've lost it. But yeah, this has not connected to the Ethereum mainnet. Otherwise, it would have constantly gone ahead and trying to fetch new blocks from the mainnet, which it is not doing. And it will not do because we have just specified what are the various network ID, port, and everything. We have specified it ourselves. That's it. Now, quickly, it's already 11:11, so I'm going to again increase a speed a notch. So here we are going to start with something like we'll start accessing one of the we're going to start one of the RPCs. We're going to use one of the RPCs, which is that we're going to use block number. ETH, again, if you remember, we specified earlier ETH, which is when we wanted to interact with the blocks, the transactions, the hashes, and so on. So ETH.block number is one of those RPCs. Right now, it will give 0 because that's, of course, there are no blocks yet. And we want to be able to start mining another RPC, miner.start. If you remember, in RPC API, we had inserted miner as well earlier. We just start miner. Now, there is an error. At this point, I would have asked you a question, but we are low on time. I would have asked you that why do you think that this has come? The error is right in front of us on the screen. That there is something very, very important that I wanted to specify here. That is why I did not do that first and rather waited for this error to come. Let me go back to this presentation once. Yes. Okay. Just a second. Where is it? Yeah. There is something very important. First of all, we have to do this. Why is this needed? What is Coinbase? A Coinbase is the first account that is, first of all, created on a particular node. And what importance does Coinbase has? The importance is that Coinbase is the account where the reward, the mining reward, you see here in the mining reward, all these blocks. If I just go to one of the blocks, and you can see that the mined by and the block reward is like 2 Ethereum, 2 plus some Ethereum, like 2 Ethereum plus some of these. If I hope you know by now, I'll just zoom in a bit. I hope you know by now, maybe that the per block reward here is 2 Ethereums, 2 Ethers. And this additional part that you see here is a collection of all the transaction fee that this particular miner has got from the individual transactions, the additional mining fee, the additional transaction fee. So you can see here, so the block reward 2 here actually goes to, okay, let's not go into that, but just take my word for it that this block reward goes to the Coinbase account, right? If you open the same Explorer for Bitcoin, you'll see that the first transaction that's happening is actually, let's try to do that. So the first transaction you'll see that happens is actually the Coinbase transaction, which is where the 6.25 Bitcoins reward for the miner is fetched, is created by the protocol and given to the miner. Let's see here. You can see this is something I, even though not a part of the demo, wanted to show you here. I hope it's visible. I'll just zoom in a bit. You can see here that this is a block. This is one of the latest blocks that have just happened. Block is 695227. You can see that 11th August 10:39 is just about 20 minutes back, 35 minutes back. This block happened. And the first transaction that you can see here is the Coinbase, which is newly generated coins, and it goes to the Coinbase account of the miner. This is where it is receiving you can see here 6.3286 Bitcoins, which means that it has 6.25 Bitcoins as a block reward. And further, the transaction fee has added to it, which makes it 6.32 Bitcoins as the reward. Again, going to the Coinbase account. That's what happened here. We have not specified a Coinbase account, so it does not know that, okay, I will start mining, but how do I get back, and how do I come to you and give you the reward, because I don't have an account to send it to. You must make, just like a Paytm wallet, you must make a wallet here so that I can give your Coinbase, I can give you mining reward to which account. So that's why it writes that Etherbase missing. We'll go ahead. We'll use another RPC. If you remember, personal is another one of the RPC APIs that we used. So we'll do personal.new account. It will ask you for a password. I'll keep it empty for now. And it just created. Please back up your key file. And now, if we see earlier, I told you that you can see here that IITM 01 key store UTC, and then you can see that this is the key in the key store directory, as I told earlier. This is where your account is created, which earlier was empty. And now if I go and I can show you here, it is not going to be empty anymore. Yeah, we are inside key store. If I do ls now, okay, it's still empty. I don't know what happened, but okay. Anyways, let's see. Let's come to that later. Why? Because it shows that clearly it is using the same directory here. So I hope it will show up. So this is where the key store file is stored. That's why the directory's name is key store. it is where all your accounts are stored. If I do again do a personal.new account here, it will again create a new key store file and it'll store there. So make sure no one gets access to this key store file, especially on your production blockchain, on this directory on your production blockchain. This is access to all these accounts. Now, how do we access that? First, something we want to do is we want to check out eth.coinbase. Again, as I said earlier, Coinbase is the account where this thing goes. So right when I pressed enter, it showed that Etherbase automatically configured. Now, which earlier the error came, Etherbase missing, Etherbase has now been automatically configured to have the first account that we created, this account. This is the address of the account. It now has access to that. So now we'll start miner.start. And this takes some time to commit new mining work. So maybe we'll wait, maybe we'll just start doing the new node thing by the time, because we are low on time, and we'll see where we go. You can see that the new mining work has started, but it's still taking some time. It takes some time. Even if you have a very fast laptop, it takes some time, even though we have specified the difficulty to be very, very low, as we saw earlier on the Genesis block. All right. So this is where we've reached. We are waiting for the mining to happen. We are quickly going to generate another node. By the time this is happening, we'll generate another node here so that we can save that time, and we can also keep in mind. Okay. Yeah, and also, by the way, when your mining is running, it will make your computer a bit slower because it takes up resources. If you don't know mining, that's how proof of work mining happens, and this is similar to that. So okay, all right. Right. Now, IITM 01 was something we created here. We'll create another node here itself, IITM 02 possibly, and we'll just go ahead and copy paste this from here. Again, we have to start with the same command. Because we want to initialize another directory, another blockchain node. So how we are going to do that is same process you followed with me earlier. We're going to do get data dir. This time we are going to name it IITM02. We're going to initialize it with the same genesis.json file. That's it. And this is done. Now you can see that there's an IITM02 as well. Going ahead, now we'll paste that, what we copied earlier. I hope it is still visible. I'll just zoom in a bit. Okay, we'll paste it. You can see here that we've again inserted a lot of items, but here is very, very important for you to follow. Even if in the next 10 minutes I have less time, I know. Even if in the next 10 minutes this mining is still taking a lot of time, does not happen, and we are not able to reach this position of committing transactions between the addresses, but still you would be having the knowledge of how to create two different nodes and run a private Ethereum blockchain network. What do you do after that? After that, what we are not able to cover here in the next 10-12 minutes, you're going to watch this video. Has a step-by-step of what we are doing. Till the end, you're going to follow along till the end. It does not have audio, so make sure you've listened to this audio that I'm telling you here. But you're going to follow there at your leisure. You can take good amount of time in doing so, and then you're going to reach out to me here on the credentials mentioned on the screen. Just take a screenshot or reach out to me on WhatsApp or LinkedIn or email, and make sure that you let me know where you are stuck. 10 minutes, we're not going to do all those things, but wherever we reach from there, follow resources, and please get in touch with me so that I can help you out beyond this lecture. All right, going back. Okay, so by the time this is happening, remember, now this time we have kept the name to be IITM02. Data dir IITM02. That means we are accessing the node in the second node, IITM02. There are some items, again, the same items I'm not going to repeat. RPC, we are using RPC calls domain star. We are using. What are we going to change? Everything else is going to be same. Network ID is going to be same. You can see here. It's becoming confusing. Please bear with me. I'm going a bit fast, but everything else is same as we did in the case of the first node. This network ID is going to be same, but this is not what we had used. I believe we had used 45451, if I'm not wrong. If I'm wrong here, then, and if you are wrong here while doing so, network ID has to be same. If you're wrong, then this node will become a node. This will run its own blockchain network, but not connect to this network as well. And you will not be able to do certain items, such as later on checking that whether both these nodes are in sync, or checking or doing any transactions. You cannot do transaction in two completely different blockchain networks. You cannot do a transaction. You either have to be connected to the Ethereum mainnet, like we all do when we want to say, for example, I want to transfer 1 Ether to MAM. I would be using the main Ethernet, the Ethereum mainnet, or one of the test nets that they have, which are Rinkeby, Goldly, Coven. All these test nets I'll be using. If I'm creating a private blockchain, a private Ethereum network, then the nodes have to be part of the same network, which is given by the network ID here. So I believe, correct me if I'm wrong, anyone who's looking at it and remembers, I believe I had used 45451 only, and I'm not able to see it here, but I believe I had used 45451. But if not, then this will not work. It will never work. It will not get attached to the same network, right? What do you change? You're running on the same computer, so things that have to change are the port. Earlier we had used 30309, so we can use 30301, or you can use 30308. It's up to you. Do not use 30309. Everywhere else, this would have been fine. On a cloud, this would have been fine. That's what a cloud does. But here, because it's the same computer, a computer has reserved, your computer has reserved 30309 as a port for running this node. So in this node, you want to change that and do it anything else, 30308, for example. Same with RPC port. You want to be able to change. We had kept, I think we had kept 8552. We'll keep here 8551, or 8553, or 8560, something like that. You get the feeling. Everything else is going to be same. Network ID is same. Other than that, everything is going to be same. Allow insecure, unlock, console, all same. I hope that makes sense. I'll press enter, hoping that it runs, and I hope that this 45451 was actually, I'm right that I had used that only. Okay, the blockchain has run, but currently I have no way to know that whether I'm part of the same blockchain network or not, because the mining has not even run here from there. Maybe we'll have to close the mining a bit. Okay, but yeah, the second node has also run, and you can see here that it has done all the required elements that it had to do. It had to start itself. It had to initialize it with the Genesis configuration, which you can see here. Initializing chain configuration, chain ID 4321, and then all the blocks specified for the forks are Byzantium, Constantinople, all as we had given in the Genesis file. You can see here we had not specified Petersburg, Istanbul, Muir Glacier, or even the London latest one, which was here, London nil. We had not done so, hence they have come nil. And I hope it's not going to create a problem here. I have not faced problem before doing this, but yeah, London came up. London folk just came up 2-3 days back, so may have created some problem here. If I come across any problem, I will update the video that I will be sharing on the resource page. If that video is updated, you'll automatically get it inside YouTube. Anyways, the second node is run. I have less than 5 minutes now, but let's go back to the agenda here. The agenda was to first create. The agenda was to first set up a private blockchain Ethereum. We have done this, and I hope it is very, very clear to you. If not, take a look at the resources video. Understanding of Genesis block, I believe it is clear now. It is the first block, and it is what you use in the Genesis file as a configuration to start the blockchain. Remember, the Genesis block is always going to be the same. Otherwise, if you're not using it, it is going to create a problem for you, and they will not be a part of the same blockchain. Add nodes to the private network, which is what we did. We created the blockchain. We added node 1, IITM 01. We added node 2, IITM 02. And both ran, and they both ran successfully, and they both followed the same configuration. We created Coinbase accounts on the first one. We created Coinbase account on the first one. We'll do the same thing on the second node as well, but we'll skip that because it's the same process repeat. Personal.new account, it's a function, and once you run it, it'll ask for a password and it'll create a Coinbase account. That's it. You can do it at your home as well, separately. Commit transaction, we were not able to do here because time is very low, but yes, follow the resources video. You will be able to do this on your own. If not, get in touch. I can't emphasize this enough. You may have to get in touch because sometimes things get stuck. Maybe because of the recent London folk that happened, things may have gotten further changed. So if I face anything, I will update the video. If you face anything, I can help you out by the time, if by the time I face and I solve it. Mine blocks, we just started. You do this by using miner.start, and later on to stop it, you'll do miner.stop. Till the time you do not do miner.stop, your mining will continue to happen. And remember, one thing about Ethereum is that empty blocks are generated as well. Even if there are no transactions, but still if this mining is going on, it will go on, and it will fetch you 2 ether every block. And also it will fetch you 2 ether every block. And once you do something like this, again, I'm telling you ETH.get balance, and then you need to give your address. So I can either copy and paste this address here. Just trying to do that, which is right now 0 because the mining did not happen. Or you can do simply like ETH.get balance and use something like ETH.coinbase, which is another keyword for the Coinbase account, which is this. You can easily do this without even unlocking the account. How? Because remember, you can check what kind of a balance a particular address has, because that's how blockchain works. Because you do not need access to the account to know the balance. Just like here, I could go to this particular pool's wallet and I can see that it has greater than $7,400 US dollars. Right? I could see that. I do not have access to this account, but I could see that. That's what a public blockchain means. Ethereum is a public blockchain. Even if you're running it privately on your computer, the characteristics are of a public access, and you can access the same without any glitch. This is something you're going to do. One thing which you'll see on the resources video is that you will start with admin.node info on both the nodes. Ma'am, can you confirm if I have 5-7 more minutes? If you can just grant me that, or are we very strict?
Yes, sir. Yes, sir. You can take some.
Okay, thank you so much. Then I'll just last 2 minutes. I'll just take questions and I'll just complete it. So you're going to do admin.node info on both these blocks. I'm going very fast. Don't need to follow the resources video, which I'm giving the presentation. You can see here that this shows you the node details of this particular node. You can see that there is an enode ID. I told you at the beginning, this enode ID acts like you're accessing IP address, and this is what you use to connect to a peer. So what do we do here, which you would see on the resource video as well, is that you're going to use the enode info. For example, this is node 2. You're going to copy the enode info from here, node 2, and you are going to use it in something like admin.add peer on node 1. I'm going to try here, but I'm pretty sure it's not going to happen because the mining has also not started yet. These are still on 0 blocks, and the node does not look like it will come in the sync, but still I'll try it out. But I'm pretty sure it won't happen right now. But once you follow the steps exactly as expected, you'll see that things will happen. And you could see that at least, even if right now they don't come as a peer, you could see that the moment I did admin.add peer using the enode ID here, of node 2. Remember, I used node 2's enode ID while doing admin.add peer on node 1. That's what it means, like self-explanatory, that it's admin.add a peer. Which peer? This enode ID peer with having this enode ID. Just like you add any a new device to a particular network, right? And the moment I did this, I pressed enter, it also started looking for peers. This was not earlier happening. This is what I'm seeing. If I wouldn't have used no discover at the beginning while setting up the nodes, it would have done this repetitively, but now it does not have to do so. But when I tried adding peer here, it started looking for peers amongst themselves. Very soon they'll become peers, or if you just follow the all these steps, mine the blocks, and then later on do this admin.add peer, you'll suddenly see that node 2 comes in very much sync with node 1 right here. All right. Once done, then there is a method called ETH.send transaction. There is a very specific method to do so, which you should see on the video. Again, you'll get on the presentation. I'm saying it repetitively because people may join and go off. So I hope at least once everyone is able to hear this. Once you do that, there is a specific way to do so. You specify the from. In ETH.send transaction, you specify the from, you specify the to, and you specify the value that you need to transfer. The value is not like if you have 18 ethers in your wallet because you've mined 9 blocks and you're getting 18 ether in your wallet, does not mean that you'll write value as 18. Remember, there is a difference. There are different units in ethers, and the unit used in this case in your blockchain network here privately is WEI, W-E-I, WEI, which means it is actually 10 to the power minus 18 in ether. It's not in ether. It's in 10 to the power minus 18 in ether. Hence, if you want to transfer 3 ethers, you'll have to write 3 followed by 18 zeros. That's what 10 to the power minus 18 would do here. That's why 3 followed by 18 zeros would mean 3 ethers. Otherwise, it will not mean 3 ethers. So make sure that you follow along. Everything is given in that tutorial video, that resource video that you'll follow along. Make sure that you follow exactly as specified there. And you just copy paste commands as much as possible. So that's it. This is where we'll leave because it's already a lot of time we have crossed. Again, this is a 2-3 hour lecture, but I hope that I was able to specify most of the details, could guide you through those commands, and at least make you understand that when we are doing something like this, when we are doing something like this or something like this, which are one of the most crucial, two of the most crucial commands here entirely. The idea was, the agenda was to make sure that you understand why we are doing something, what data DIR means. That's where the blockchain is stored. What RPC means, what RPC coarse domain means, what is special about network ID, why not to use 1, 2, 3, 4, or so on, why to use a randomized value, which are the RPC APIs that you need, ETH, Web3, what do they individually do, which port to use, how much random the ports need to be, the ports need to be different, the network ID needs to be same, and so on. I hope this was clear, and it was clear about why to use the same Genesis block. There is nothing like a same network but different Genesis blocks. It does not happen. All your nodes must be initialized with the same genesis.json file. If you want to change anything, make sure that you change the Genesis file and then you reinitialize those nodes, which would mean that they will be fresh new nodes. You cannot just suddenly go ahead and in a running blockchain change the Genesis file. Remember, blockchain is immutable. You cannot go back and change something. Whatever you're doing, you starting fresh, right? And what we could not cover a lot is given here. Important RPC calls. You can see ETH.block number we did, ETH.getBalance we did some of these, but many are there which we haven't done, and this is just ETH, right? Then there is Web3, there is personal, there is admin, like admin.nodeinfo. All of these you'll find in the resources section here. References for important RPC calls and documentation. I've made sure that I put every command and everything here on the PPT, which you'll get. Otherwise, just reach out to me here, please. My credentials are there. I'm pretty much accessible on all these platforms, and make sure that I help you, because 1 hour is not sufficient for this entirely, but we don't have 1 hour. We can take as much time as we want. We can take a weekend and we can solve things as needed. That's it. If any questions, maybe in 2 minutes, if you can have some questions, then that'll be great. Otherwise, please feel free to touch with me. And by the way, ma'am, before I hand over, there is a feedback form I'm sharing. This is a 10-second anonymous feedback form. Please do fill it. You can fill it from your phone as well. And if you're giving a 5, I'll be very happy, but please do make sure that you let me know what went so well, and otherwise what can be improved. Anonymous takes 10 seconds. Yes, thank you, ma'am. If you can just, ma'am, you need to write this. I don't have access to the chat. You need to write this.
Yes, sir, sure.
Yeah. And the capitalization is important, like F is capital here. So it's just like bit.ly/10-second F capital. That's all. But I can't copy it to you.
Yeah, I will do it.
Sure. And by the time ma'am is writing it in the chat, if you have any questions, maybe we have 1 or 2 minutes that I can be granted. Otherwise, we'll close here.
The chat will. And any question? Any question from the participant side? All right. We are just putting the feedback, this link in the chat window, and the IITM chat like feedback form will also be there. I request all the participants to fill that feedback form. So you have 2 feedback form for today for the morning session. Kindly do the needful, please. All right. Thank you so much, sir. In such a short duration, online demonstration was given how to set up a multi-node private Ethereum blockchain. We understood about the Genesis block and how to add nodes to the private network. All this information was very much valuable, sir. And thank you so much, Abhishek, sir, for taking out a valuable time. Thank you, sir.
Thank you. I'll just stop sharing.
Okay, sir.
All right.
Sir, now can you switch on your camera, please? We need to take
Yes.
one photograph also.
I did that.
Yeah. Photograph. All right. Moving forward, let's welcome to the next speaker of the day, Mr. Raj Changanti. Mr. Changanti worked as a security engineer in a security team at Expedia Group Inc. to detect, mitigate, and respond to the security threats in a large-scale enterprise organization. Currently, he is also involved in security research and working towards PhD degree from University of Texas, San Antonio. He is holding the industry certification such as AWS Solution Architect, Certified Ethical Hacker, and CCNA Cyber Ops covering various aspects of security. His research areas are in machine learning, AI for security application, network security, threat detection in IoT, cloud and blockchain environment, and social engineering. I would request Mr. Raj Changanti to enlighten us with his knowledge on blockchain application in cybersecurity. Over to you, sir.
Yeah, thank you, Dr. Tripti. It's really awesome to be here, and thank you for the great introduction. So, by the way, I am Raj Shaganti, so I'm very glad to be here, and let me start my presentation if I can continue.
Yes, sir, please.
Awesome. So, I'm going to share my screen.
Yeah.
Can you see my screen?
Not yet, sir.
Yeah, it's probably getting delayed due to internet connectivity, I guess.
Maybe, yes, I think it's coming now. Yeah, it's there. Yes,
awesome. Yeah. Thank you so much. Today the topic is like blockchain applications in cybersecurity. So I think so. We had awesome sessions earlier, and I'm glad to see like we had a wonderful another session regarding walkthrough on Ethereum. But this is going to be more of theoretical aspects. In particular, I'm going to cover the blockchain applications in cybersecurity. These are like two cross disciplines, but I wanted to like describe the different cybersecurity areas, like and how we are going to use the blockchain, particularly the private, public, and semi-private as well. Let me start. Already, I mean, Dr. Tripti has given introduction about me. So currently, I'm working on network security, particularly focusing on distributed denial of service attacks in SDN, and also working on securing the blockchain as well, and remaining areas that I've been continuously working on as well. So let me start with the outline today. So the main agenda of today's talk is to be like to get to introduce like the cybersecurity like different areas and how we could leverage blockchain to apply in those areas. That's one of the main aim of the talk. So I'm going to talk about the introduction to blockchain. I'm sure about like you all have been through all the details of the blockchain, but I'm going to give a very short introduction, and then I'll start off with cybersecurity core areas and how could we, and then I'm gonna parallelly the second and third point, like I'm also gonna start discussing about the blockchain applications in those core areas, and later the second part is basically just like what are the different attacks that can be done in the blockchain ecosystem as well, and then the conclusions. So introduction to blockchain. So it's basically a chain of blocks. So all the transactions that we usually store in a blockchain, these will be stored in a block, and each block will be connected to the next block using digital certificates and public key encryption, so and here you could see that like the blocks, three blocks, which were like continuous blocks, block I minus one and I plus one, which could be thing. And in each block, you could see all the transactions which are stored in representing with TX. and a transaction counter, which is gonna count the total number of transactions. Along with that, to store the metadata in each block, we have a block header, which contains like the metadata, like block version and Merkle tree. Merkle tree is basically when we wanted to check query any particular transaction and wanted to verify the hash, then Merkle tree, it's gonna go through like a decision tree, and it's going to pick up that particular hash. In addition, and also like the timestamp, these are all other metadata that are stored in block header, and to keep track of the connection between the next block, the previous block. So that's going to be the parent block. The parent block hash would be stored in the current block. And a couple of other terminologies that should be aware of it, like it's a distributed ledger. So basically all these blocks will be stored across all the different nodes, whoever it's operating the blockchain node. So these nodes will be connected using the peer-to-peer network protocols. So the first peer-to-peer network protocol, which was usually used familiar protocol. It's gossip, basically used in Ethereum and Bitcoin as well, to basically ping one.
Raj sir? Raj sir, am I audible to you? Raj sir? Raj sir, am I audible to you?
Yes, ma'am. Can you hear me?
Yeah, now I can hear you. I think you were muted.
Oh, sorry.
Yeah.
So I'm not sure, like, when did it has been like muted. Like, I'm gonna. Okay, let me gonna start, like, okay, that's
right. No, initially it was fine. Yeah.
all right.
Yeah.
So I believe, like, I have done the blockchain stuff, right? Yeah, let me just gonna give just a brief like discussion about, like, the chain of blocks, basically. And we have so it's gonna basically it's a distributed ledger. So the blocks will be stored across multiple nodes in the blockchain, and all these nodes will be communicated with one another using either uh, uh, gossip protocol, if we consider for Ethereum, or Bitcoin. And to perform mining, we have like consensus algorithms, which could be either proof of work, if we consider for Bitcoin. And so right now, Ethereum is moving to Ethereum 2.0. So that's basically, so they are moving from proof of work to proof of stake, so that they could save the energy. And we have another consensus algorithm, which is like delegated proof of stake, in which so all the members in that blockchain, so usually vote a particular miner, and he could be able to perform the mining in that particular blockchain. So yeah, so let me walk you through the different blockchain components which were present. So if you see the diagram, we have so a cloud network in which couple of Bitcoin nodes has been installed, like Bitcoin full node, so which has the capability to store all the blocks, and also which could perform the mining as well. So the famous, like the full node, it's like Bitcoin core, but it requires a lot of memory. It's like at least 500 GB at this particular point, like, to install that full Bitcoin core in our mission. So which is gonna store all the blocks that has been there since the Genesis block. And these are connected to edge router, so which could be either installed in AWS or Microsoft Azure. And also, so if someone is installed like Bitcoin Core in his home network, then the corresponding ISP edge router usually connected to the internet. And we could also use like the SPV wallets. So if we just wanted to use for just transactions, so SPV wallets usually connect to the nearest full node, and the nearest full node perform the transactions and even like the mining operations on behalf of the SPV wallet. And in addition to that, so if we see blockchain, so most of the times like we use blockchain services. Usually we create a username and password, and they perform the blockchain the mining on behalf of us. So it's basically they usually map our usernames and passwords with wallet, and they perform the main heavyweight operations on behalf of us. Apart from that, on the right side, you could see basically the mining architecture, where we have pool nodes and also the pool protocol server. These pool nodes could be anyone, like anyone could join those pools, like whoever install that application. And these pool servers, they usually allocate they divide the work to solve that puzzle and distribute them. And also, like whenever like these nodes perform their task, and it's going to corroborate all this work and perform the mining. These are like the basic building blocks that we usually see in blockchain. And the next one, so the different types of blockchain, as we know, like so public blockchain, these are permissionless. So we could literally check the users in terms of like, even though they are anonymous, we could check their user IDs, and also their transactions, like whatever the transaction they were performing. So for example, Bitcoin, we can literally see like who is doing like in terms of like even though they are anonymous, we could see the IDs. And federated or consortium blockchains, these are like private blockchains, but multiple organizations can use that to perform the transactions. So for example, Energy Web Foundation, which is basically for exchanging the assets and also performing the transaction between the smart energy community, in which like multiple stakeholders were involved. And another example is R3, which basically works on blockchain platform Carda. So this was it was started by 9 banks for exchanging the financial transactions. So, and the other one, private blockchain. So these were any organization who wants to build their internal application and should not be exposed public, and they could use the open source, like like a Hyperledger, and they could build their application internally, and they could literally set up the roles and to increase the role-based access control, and having more security even internally inside the organization. And the fourth one, this one, hybrid blockchain. This is basically bridging the gap between the one like in organization. If someone is trying to adapt blockchain and it's completely works, I mean, we need to have a different frameworks. And for example, if we take Ethereum, we should know we should be working in Solidity, and the employees who are working, they might not be they may not be professionals in this blockchain technology. So so this, I mean, so they could use a hybrid blockchain, which basically, so we could use our any development platforms, and and we can write the code in our own platforms, and basically the Dragon chain, which would convert the code into their private chain. It's going to automatically convert the code into according to the semantics of Ethereum, Bitcoin, or other blockchain technology. And then the Dragon chain is going to communicate with the public blockchain, that is the listed Ethereum or Bitcoin. It's basically bridging the gap between the knowledge. Okay. Okay, so let's look at the cybersecurity core areas. We have a threat intelligence and vulnerability management, security incident and response, and network security, governance, risk and compliance, and malware analysis and reverse engineering. Still forensics and IoT security. So the idea is to how could we use this? The blockchain, this core concept, and how could we apply in this different areas. Let's get into what is cyber threat intelligence. It's basically whenever any organization so to up to date with the current threats and updating their databases with the current indicators of compromise. They need to share the information from different. They need to get the information from different sources, as well as they need to share the information to other stakeholders to get up to date, and probably in case if there is any incident, and they might have to share all the the indicators of compromise and details as well with government, and sometimes and small businesses which do not have the security team, and they probably have to work probably sharing with system engineers. That would be a good case, where sharing threat information. So there are the information could be threat or vulnerability or technical intelligence or threat actor. So technical details could be when any security team member, so he is working on any particular incident, and he would get he would find the malicious IP addresses and domains and other artifacts, and file paths that any particular adversary is using, and they could literally they can share these artifacts and get and available to public, so that every other team knows about this, and they would update their security tools as well with these IOCs and threat actors. So there are multiple advanced persistent threat groups. They actively building new tools and start. And trying to hack as well as expose as many organizations as possible. So sharing that information, and everyone have their own traits, and also that also would be helpful to get ahead of threat actors and threat information. Particularly any particular target industry they should be focusing on, and the different techniques they use for a particular threat, that could be shared as well. And vulnerabilities, for example, any new zero-day vulnerability in public, so this has to be shared across across different community security communities, or any other allies with they are working. So these this information can come from different sources. It could be open source intelligence, and technical intelligence, and human intelligence. Someone who is working with has been working and he's hitting, and another one dark web intelligence. Anyone which was happening in the dark web, and there are some service providers who constantly crawling those dark web pages, and they perform they use machine learning and AI algorithms to pass that information and provide more meaningful information that could be used to update the organization's security threat defense. So how could we use blockchain in CTI? So if you see on the right side, you could see it's a very brief diagram where you could see so the CTI feeds which could be coming from different sources, and the contributor who is a researcher who is working on doing research, and he could update that information as well. And miners could be anyone who is performing a mining as well. Uh, he could be a contributor as well sometimes. So anyone for example, a consumer would like to request information, so he would query the blockchain, and so he would get the information, and he would be charged for example, if we take Ethereum, it could be a gas, and also and whenever someone is updating an information, for example CTA feeds, and they would be rewarded as well. This is very basic way of using blockchain to update the threat information. So here the transaction should contain either IOCs, threat technical intelligence information, or the threat information, etc. And vulnerability management. This is another important part of cybersecurity, where it's very straightforward process. We scan the assets, and then we identify the vulnerabilities, then classify and prioritize the vulnerabilities, then remediate those vulnerabilities, and probably the mitigation and other proactive steps to reduce those vulnerabilities in future. And this will be scheduled weekly, monthly, and daily. A couple of industry standard products like Qualys, Tenable, and Rapid Expose. So blockchain in VM. In vulnerability management, we have different team members, so should be working when a vulnerability exists. So the security engineer should be performing a vulnerability scanning, and then the net, and if it is related to, if they find any vulnerability in servers, and they should be working with the owner of the server, should be mostly a system engineer, or if it is a vulnerability in the applications, should be working with application engineer, or the network engineer if it is a network device. So it's very like chaos in a big large enterprise environment, where multiple stakeholders should be working on mitigating these vulnerabilities, and tracking the activity, who is doing when what, and who is working on which vulnerability, and it's really a very cumbersome process, if you wanted to track using. So here I think blockchain would be handy. So just using any private hyperledger, private blockchain like Hyperledger, they could set up their own the blockchain to track all this activity, timestamp, and the scanning application that they were doing, and who is actually initiating that scan, and the location where that device is deployed, and in fact even the role-based access control can be employed, so that the roles can be segregated based on their roles. And yeah, and another area is security incident and response. This is pretty much this team is responsible for responding security attacks, in 24/7. So there are different roles, tier 1 analyst, tier 2, and senior security analyst, manager, and senior manager. So the coordination here is the key, because every ship setup team members should be working, and when their shift is done, like they should be handing over their work to the next team members. So here again, tracking would be another an issue. Again, just using blockchain, like the private blockchain is really handy here as well. And a couple of things that can be done using blockchain is that, like, tracking the incidents, like, who is doing what, and also and maybe an analyst blocking a particular IP or domain, and so he should be performing these activities on a particular network firewall. So all this information on a particular time, all this information should be helpful, so that the next analyst who is actually working on the same incident, so he would be able to continue working on that, and he could track actually what has been done. So they could so there is no repetitive work as well there. And even like maybe the leadership, the manager, he could be able to track who is the activity using Hyperledger. So yeah. And in addition to that, sometimes maybe if an employee mission is being compromised, and probably they might have to share their file with password protected, and then probably then using a IPFS kind of peer-to-peer storage capability. That would be an easy way to track all the malicious files, and also we can also use the hash value of that and store it in blockchain. That way we could track all the files like that has been like investigated, and their disposition, whether it's malware or benign. That is another use case that blockchain could be really helpful. And also, like most of the times when really someone compromised any any asset, so they probably one of the task would be like to delete all the logs, like when they were having a blockchain and storing all the log, whoever is accessing the logs, and that information storing as a transaction, that would be also another use case that can be used, in a private organization. And the next one, network security. So there are a number of attacks which maybe like layer 2 attacks and layer 3 and layer 4 attacks, starting from ARP poisoning, man-in-the-middle attacks, and also IP spoofing, and performing different flooding attacks for denial of service, and distributed denial of service attacks as well. And out of that, like two major attacks which were we often see, one is like botnet, where the IPs should be coming from multiple from disparate like locations, so it would be difficult to just block or tracking even those number of IP addresses. And another one, just performing application and reflection attacks, where they are trying to shut down the DNS servers, so that the whole network just around which are like depends on that DNS services, those will be shut down as well. So how can we use like now blockchain to mitigate the distributed denial of service attacks? So this one actually I have actually borrowed from one of the recent work to just give an idea. And here, so we have, so we could use software-defined networks, which basically have a single controller which would control all the network devices, and can be updated their flow table, and we can write the security application on top of controller as well. So here, if you see, like we have three different autonomous systems: source autonomous system, intermediate autonomous system, and destination autonomous system. So here, so we get to know that, like, so that there is an IP address that we would like to block, because we find a malicious IP address, and this was actually performing distributed denial of service attacks on different other autonomous systems. So whenever we find that, then the uh, controller is gonna update this Ethereum node client, which was residing in the same autonomous system, and this is gonna update to the smart contract, which basically gonna update the IP address and the corresponding action, whether wanted to allow or block, and this will be propagated across, like, uh, the Ethereum blockchain, and it will trigger an event and to update all the other autonomous systems. So this is going to update this controller, and this controller will instruct all these switches to update this IP, the flow table with this IP address, and the action would be blocked, so that so that this IP address from this destination is trying to flood with any of those autonomous systems, which could be blocked at the switch level itself. This is one of the example, but if we wanted to implement this mechanism, so first of all, like, all the ISPs should agree and should deploy this Ethereum node, and most of those the ISPs networks, those are legacy networks, and adopting the decentralized peer-to-peer network, which is really not an easy process, and they should all align, like, to accept to deploy the Ethereum client as well. And also these IP addresses, these are like ephemeral. They just the adversary can simply use another IP, the public IP address, or like since we have right now the IPv4, IPv6, so it's very easy to pick some other IP address. They just change the IP address, and they're going to start, like, still continuing the distributed denial of service attacks. And another like most of the another attacks that could happen on domain name service, which basically someone is sending a DNS query, and the reflection and the DNS response would be much more larger than the packet size, the request size. This way, the victim that is targeted, like with along with the spoofing, it should be basically performing a distributed denial of service attack on any of the victim. So so can we have any decentralized domain name system? Right now, in fact, like the Bitcoin or Ethereum, these are all, like, works on decentralized domain name system. They have, like, for example, Ethereum, Bitcoin, which has, like, 5 name servers, and in fact, like, these are all decentralized domain name systems. In case if any of them, like, I mean, so yeah, that's a different talk, but probably I would talk later, in case the real attacks on blockchain. But right now, yeah. So let's talk about the legacy domain name system. Like, what are some of the issues? So if we wanted to register a domain, we should be going to registrar, and then would be paying money, and then so to get registered. In case if so we should be relying on registrars and registry operators, and also this DNS servers. These are all prone to DOS attacks. And even, in fact, even though DNS servers were not involved, if someone wants to target, it's really very easy to target the DNS servers as well. And these are all prone to, again, the cache poisoning. Anyone could simply change the IP and domain name mapping in any host file, for example, in the local cache, local host file. So it's basically pointing the cache. So it's very complicated hierarchy where we have like first local host, and then it's gonna query the authoritative name servers, and if still didn't find, then it probably has to go to the root servers to get the data. So having said that, so probably a DNS solution which is decentralized, basically, in which each transaction should contain the register the domain name, so that this will not be repeated once again. Like these will be stored and permanent in the blockchain. And for example, like, so we have some applications, I mean some real-time products as well. So Handshake is one of the product which is like which could be used for decentralized domain name registration, as well as, in fact, even they provide public key, these certificates as well. Sorry. So next, so, and also, I mean, there is another area, like it's governance, risk, and compliance. This is particularly mostly in the in any particular organization where what kind of policies put in place, and the standard procedures that they should follow to align with standard, like organization standards. So I mean, so I think I can't emphasize more enough that, like for auditing, blockchain is really anything that we would like to audit. Definitely, blockchain is has like a lot of potential that we could use. So for any internal audits, for any compliance purposes, like PCI DSS, and any ISO other compliances, like then for internal and IT audit purposes, we could literally use a blockchain. So just setting up a private blockchain, and just the transact then storing any info, all the evidence that they have collected from as per the compliance requirement, that could be stored in the IPFS also, and whoever is accessing that can be stored in the transactions. And also any change management and policy management, any changes to keep track of like any changes happening around, like for policies, and any servers or any assets based changes, like adding a new policy to firewall. Then those change management should be tracked, and storing in blockchain would be really a great advantage there as well. And for storing all the third-party vendors, any organization, they should be having some third-party vendors. They should rely on that. So and we need to make sure that all those third-party vendors are like aligned with the compliances, and just keeping track of like whether they are aligned with all the compliances, and all the additional information regarding the third party, maybe like if they have been like victim of any breaches, and that this information could be like updated in the transactions as well, so that we could track like the third party, all the third party vendors that any organization that they should be using. And similarly, enterprise risk management as well. So internal any threat. So I mean, risk management, like this, it's an evolving process. So it's based on the type of incident that they should be seeing in an enterprise, and they should be updating their risk strategy. And these details probably can be stored in the blockchain as well. Yeah, I think most of I mean for the GRC, so which we just require again the private blockchain, and the data that should be stored, like it's mostly in terms of like just the log information. But the problem could be so we should, right now the existing compliance standards which are really not useful, which are really not aligned with the blockchain technology. So yeah, we probably still have to wait, like until we have some standards and and accept blockchain, and align with all those compliances. That's still in process. um, and and another application like in cybersecurity, it's like another area like malware analysis and reverse engineering. So even though except just storing the IOCs, IP addresses or domains, whenever someone performing an analysis on any file that we have discussed, when we were talking about threat intelligence. And it's pretty much like the application would be very minimal, because mostly malware analysis is specific to any particular file or any image, and even in reverse engineering also. But except maybe keeping track of all those file hashes, that could be, but and we'll have to find the particular application, why we wanted to do that, store that transaction and all. Apart from that, very limited application that I would see, like using blockchain. But maybe performing a malware analysis and reverse engineering on blockchain application, that would be something interesting. And the next one, digital forensics. Yeah, I think this is one of the most important, I think, and one of the there's a lot of potential, using blockchain, that is like in digital forensics, because there is a chain of custody which basically keeping track of, like the evidence moving from one person to another person. This is proper application for blockchain, where we could store all that information, like the chain of custody, like who is actually and who is handling that evidence, and the timestamp, and any file hashes of that evidence, that could be stored in blockchain. So here we could see it's an example of using Hyperledger to store the evidence, like is basically starting from first responder. This could be like security incident and incident responders. They would collect the data, evidence, basically the evidence which is coming from either acquisition, like through electronic device image, or getting the logical data from the logical drive data from the cloud assets. So and when they perform the analysis, so using the basic tools like Kane Linux, Kane is basically a distribution which has all the digital forensic tools that we could use to perform the forensics, and all that evidence, this could be transferred to the forensic investigator, and he could perform the investigation from his side, and then so whenever he performed, whenever he transferred, and it should be passed through a chain code which is similar to the smart contracts in Ethereum, and updated to using consensus algorithm. This could be like proof of work in this case, since it's Ethereum, and then it will be updated to transactions, and then it will be passed on to a prosecutor, defense, and court, just making sure that, like the integrity is not like disrupted. Yeah, and yeah, IoT security. So for IoT security, mostly rather, I think there is a lot of, so the number of applications, it's a huge, like pretty much like it could be like smart health, smart transportation, smart grid, and smart industries, and a lot of research work has been done in terms of using blockchain and for data authentication and integrity and authentication, authorization, and privacy, and just again keeping track of all the log events, like to maintain the integrity of the log events if someone is trying to delete or and also managing the certificate authority in IoT. So this is mostly, I mean, though I don't think like it will be useful in industry. I mean, at this point, like the applications are limited, but in terms of research, I mean, yeah, there's a lot of scope, since like these IoT devices are having, I mean, low memory and CPU and power consumed devices. Yeah. So this was so far what we have seen is that like these are like that the how we could use, I mean, so blockchain to in the security, in the cybersecurity application. So and another aspect is like how, so what are the different attacks in blockchain ecosystem itself. So I think so one of the, I mean, advantage that we say like blockchain, it's security. So it has like anonymity and integrity, and even and if it is like private blockchain, even the confidentiality would be achieved. But still this denial of service, that's unavailability basically. So that's still an issue with in the blockchain, it's even as well. So if you see the diagram, so we have like the different blockchain component that we usually see. So this one, it's a Bitcoin on the left side. So this one, actually the internal components of a Bitcoin full core node, so which has the capability to store all the incoming transactions, and also performing mining as well. And so we have a mempool which basically stores all the incoming transactions until a particular any miner who adds that block to the blockchain. So here, if an attacker like targeting any particular particular node, not particular node, I would say, I mean, so a mempool, and send small amount of I mean multiple transactions, like with small amount in each transaction. So basically trying to flood that mempool. So that could be denial of service attack in blockchain. That's basically going to interrupt all the incoming transactions until the mempool is getting cleared. And if you look at on the right side, it's the mining pool. So these mining pools basically, due to the competition or maybe some some adversary mining pool node pool, they basically target this mining pools, and they perform the denial of distributed denial of service attacks, which could be a normal distributed denial of service attack as well, like just using some botnets and just sending the traffic to consume either the communication channel bandwidth or any server resources as well. So and the another type of attack, it's a Eclipse attack. So every Bitcoin node which has like, probably if we take Bitcoin, Bitcoin, so which has like 118 outbound 118 inbound connections and 8 outbound connections. So that is very very less. So if someone is trying to really target any particular node and they just wanted to disrupt their services, they simply send 6553, it's like 2 power 16 minus 1 TCP connections, and it's basically consume all the resources of that node, and it could be distributed denial of service attack as well. Those are the Eclipse attacks. And another one is like partitioning and delay attacks, is basically at the BGP level. So if someone compromises get handle of any BGP prefixes, and they can basically control any particular node. So, for example, if we take an attacker, he wants to just perform a distributed denial of service attacks on this particular Bitcoin node. They can compromise any core router and the BGP prefixes as well. So he's going to manipulate that PGP routing table so that all the requests that are coming from this the packets that are coming from this Bitcoin core node, these will be stopped at the core router as well. So it's basically not going to talk to any other Bitcoin nodes in this in the internet after certain. So it keeps pinging on the core router, and it will be it wouldn't see any a response from the core router as well. And another attack, that's the transaction malleability. This is basically happens when for example, I would say, like, for example, so we have someone is trying to perform a performing a transaction using any centralized exchanges. So they first start using they use their wallet and start performing a transaction, and the ID, the unique ID that will be generated, and he would receive that that ID, and basically centralized exchanges would be able to receive that ID, and next he would also perform another. The same transaction, which just changing the transaction ID, and he could be able to send it to the core node. And in case if the first one that is stored in in the centralized exchange, and the second one that he started later, like by manipulating the transaction ID, and if it is gets succeeded and gets added to the blockchain, that will be that will be added to the blockchain. And the second one will be still at the centralized. The centralized exchanges thinks that this is the first one is already is a successful one, but it's actually not. So the attacker basically charging from the centralized exchange at the same time, so you would be able to perform the second transaction that will be added to the blockchain. These are some of the core attacks that we could see, and there are like many other, but majority these it comes under these are these following different types of attacks. Overall, the conclusion. I think the blockchain adoption in cybersecurity is still in early stages. It could be due to maybe particularly if you consider for an enterprise level, it's probably due to the compliance purpose. Maybe some startups, and they are trying out different applications for private applications, for private internal applications. But still there's a lot of scope, like to use blockchain in different cybersecurity applications. And another thing, like the attacks in blockchain is still a major concern. For example, in fact, today, today there has been an attack, and which they they have stolen from one of the Bitcoin, the cryptocurrency platform, $600 million. That's one of the biggest hacks in in the cryptocurrency. That happened today. So yeah. Any questions?
Yeah, any question from the participant side? Sir, you can stop your sharing.
Okay.
Right, and you can switch on your camera also, sir. All Fine. Any question from the participant side? All right. I would like to thank Mr. Raj Changanti for such an elaborate and informative session. Sir, you talked about security incident, smart contract-based distributed denial of service mitigation. Then you talked about governance, risk compliance, the attack in a blockchain ecosystem, and how it is vulnerable to denial of services. Thank you so much, sir. Now that we have come to the end of the third day of our faculty development program, I would like to express my immense gratitude to our speakers for their valuable time and words of wisdom. I would like to thank all the participants for joining us in this session. The session will resume tomorrow at 10:30 a.m. Thank you so much. Can we have a selfie photograph, please? I request all the participants to switch on the camera. And I request all the participants to fill the feedback form also for both of the sessions. आप लोग का कैमरा ऑन नहीं है. I request all the participants to switch on the camera, please. All right. Thank you so much, everyone. See you tomorrow.
Thank you.